In today's video, we'll talk about space and time, that is space-time. According to Einstein's general theory of relativity, what we perceive as gravity is actually the curvature of space and time. But what is space and what is time? The amount of area, room, surface that is empty or available for use is called space. Space is three-dimensional. But what are dimensions? Dimensions are known by length, width, and height. The dimensions create a 90-degree angle with each other. In two-dimensional, we can add another dimension into this by adding a 90-degree angle. If you were to add another angle into a three-dimensional space, that would form a fourth dimension, known as time. Time is the indefinite continued progress of existence and events in the past, present, and future regarded as a whole. In simpler words, time is a point or period when something occurs. The faster you move, the slower time takes for you, relative to the observer, of course. According to Einstein's general theory of relativity published in 1915, the stronger the gravitational force of an object, the slower time becomes around it. For example, a black hole. If you were to move closer and closer to a black hole, the slower time would take for you. This is due to the curvature of space-time. For a person in space, time moves differently as compared to a person on Earth, which can be proven by the twins' paradox, which is by sending one twin into space while the other remains on Earth. The twin on Earth will age differently and faster as compared to the one in space. This is due to the time dilation in space, which is slowing down of a clock as determined by an observer who is in relative motion with respect to the clock. So basically, time dilation refers to the idea that time is relative and passes at different rates for different observers. So keeping twins' paradox under observation, time is dilated for the twin in space. However, time remains the same for the one on ground. There are a few different theories regarding space and time. According to relationalism, space and time differ from person to person. But according to absolutism, space and time are fixed for everyone. However, this theory is obsolete nowadays because how can your red be my red? For a color you may perceive as red, it is very much possible any other person may see it differently, and there is no absolute way of checking that. Moving back to our topic, time. If you were to meet someone anywhere, not only are you going to mention the three-dimensional space, that is length, width, and height, but also the time. Time as in the fourth dimension. If one day we were to discover a fourth spatial dimension, time would become the fifth. As time will always be there in our lives and there is no way of eliminating it. To conclude, space and time are inextricably linked. Moving through one affects your motion through the other. Space and time are fundamentally the same thing, or at least two different sides of the same coin. Well, that would be it for today's video. If you guys enjoyed it or found anything helpful, make sure to give it a like and subscribe if you want to. I'll see you in my next video, whenever that will be.